Hi everyone. Today I'm talking about free fall in more detail, and so let's start. Like I said in the previous video, because of Earth, all objects are attracted to the Earth. If they have some height with respect to Earth, then they fall down towards the core of the Earth. So, and then I said the acceleration due to this free fall is roughly 10 meters per second squared. 10 meters per second squared means in every single second, the velocity of the object that's at some height with respect to Earth gets increased by 10 meters per second, which means if I just drop a ball from a building with velocity of 0, after 1 second, it becomes 10 meters per second. Second, it becomes 20 meters per second. Third second becomes 30 meters per second. So on until it hits the ground. So this means acceleration of 10 meters per second squared. Okay. So now, what if I tell you, fine, I understand all this jazz about, velocity getting bigger and bigger, but how would I search for the height of a building? So let's say I have a ball here and I drop this with 0 meters per second, and I drop this guy from this height, and I want to measure the height of this building. Knowing that, it reaches the ground after maybe 4 seconds. So, of course, if you know G is 10 meters per second squared, then after first second, it becomes 10 meters per second. After the second becomes 20 meters per second. After third second, the velocity becomes 30 meters per second. And after fourth second that hits the ground, the velocity is 40 meters per second. But now, fine. Okay, so that's the final velocity, etc., etc. How would I search for the height of this building? I do understand that velocity is displacement over time. And I know my time is 4 seconds. See? But how would you judge about velocity if velocity is always changing? See, I'm starting from 0 and I ended up with 40. I never was going always with 10. I never was going throughout this whole motion by 20 and never by 30. The motion was such that the speed, the velocity was all the time changing. And that's why we actually had acceleration, because acceleration essentially means change in velocity. So the velocity has to be changing in order for us to be having some accelerating motion. So saying that, I know my velocity is not a constant number here. So my question for you is, what number would you put instead of this velocity here? If you would be going with constant velocity of, 25 meters per second, yeah, sure, that was constant. So, and you already know how to solve those problems. Now that the velocity changes, in order to be fair, we need to take average of this velocity. What we do is that we take the average velocity and we choose, let's say, the first and the last, 0 plus 40 over 2, and that gives me 20 meters per second. Okay, so that becomes 20 meters per second, and you're good to go. So overall, it's as if your speed was always 20 meters per second because it was between 0 and 40. So on average was 20 meters per second. Now, in order for you to solve for the height, then you know what to plug in for your velocity. You plug in 20, and that equals x over 4 seconds. And then you solve for the x, and that turns out to be 80 meters. So the height of the building is indeed 80 meters. The ball covers this 80 meters in 4 seconds, starting from velocity of 0. Okay, so that's the first thing I would like you to appreciate. Appreciate the fact that because the velocity is changing all the time, therefore we need to be taking the average of the velocities, namely the first and the last, and divided that by 2. The other thing I would like you to appreciate about free fall is the fact that free fall is a symmetric motion. What I mean by symmetric motion, I make that clear in just a minute. So let's see what I mean by symmetric. So when I tell you free fall is symmetric, it means that, I have this earth and we live on this earth from the time we were born until probably we die. So it's just there, and the acceleration due to gravity is 10 meters per second squared. And so let's see. Well, in all the problems and examples, I told you I'm dropping something. So you always, you're used to having the velocity, increasing all the time. But what if I tell you I'm throwing something up? So if I throw something upwards, then we know it's gonna stop at some point. Here, stops, which means its velocity becomes 0 meters per second. But what is the fashion of this slowing down motion? Let's see. If I throw it up, if I give it some velocity, let's say 50 meters per second, if I ever do that, then because of acceleration of 10 meters per second squared, in every single second, the 50 meters per second gets decreased by 10 meters per second, which means after 10 seconds becomes 40. Another second becomes 30 meters per second. After another second becomes 20 meters per second. After another one becomes 10 meters per second. And then the last second, which is 5 seconds after that, see 1, 2, 3, 4, 5 seconds. In 5 seconds, it stops. So 10 decreased by another 10 gives you 0. And then if I drop something up, if I throw something up by 50 meters per second, then after 5 seconds, because the acceleration is 10 meters per second and per second squared, after 5 seconds, it stops. It stops, but we know this guy exists. Earth exists regardless of anything happens. Because Earth exists, when it stops, it's not gonna be in the air forever. It's gonna fall down. Why? Because all the time, this guy, Earth, was pulling it towards itself. And that was the reason why actually 50 meters per second becomes 0. Because all the time, this Earth was pulling it towards itself. Trying so hard to make this guy stop, which eventually it was a victory for it. And now that it stops, then come to me, right? So I would like you to appreciate the fact that motion, the arrow for motion is arrow for velocity. I would like you to understand this. When I say I throw the ball up, the arrow for velocity shows me towards which direction the ball is moving, right? Arrow for acceleration, though, doesn't have anything to do with the motion of the object per se. Throughout all this upward motion of the ball, when I throw it up, I always have acceleration downwards. And that's why, because of this opposite direction of velocity and acceleration, it stops at some point. because although it was moving up, this guy was pulling it down. Okay? And then it is symmetric because you're having 50, 40, 30, 20, 10. Now, when it comes back, it's 10, 20, 30, 40, and 50 when it hits the ground. So arrow for motion is arrow for velocity. Arrow for acceleration doesn't have anything to do with the arrow for motion. I'll explain in other videos more examples. Bye-bye.